Imagine having an AI assistant that's not just, scheduling your meetings, but it's actually designing your website,
Oh, wow.
brainstorming your next big business idea,
Yeah,
maybe even whipping up a gourmet meal based on what's in your fridge.
that's pretty impressive.
That's the kind of mind-blowing potential we're talking about with artificial general intelligence or AGI,
Yeah.
AI, that can tackle any intellectual task a human can.
hmm
You sent us a research paper to dive into how far are we from AGI?
Yes,
And it really gets into the nitty-gritty of what it would take to create something like that.
it does.
It tackles this question from all angles,
Yeah.
what an AGI mind might look like, how it would interact with the world around it,
Yep.
the systems you'd need to build to support it,
hmm
and of course the ethics of creating something potentially smarter than ourselves.
Absolutely. It's a fascinating paper.
Yeah,
And it really highlights just how complex a challenge this is.
right.
It's not just about building a faster computer or writing more clever code. No.
It's about understanding the very nature of intelligence itself.
Right, because we're not just talking about AI that can play chess or write a decent email.
Right.
We're talking about AI that can understand the world the way we do, reason about it,
Yeah.
learn from it,
Uh-huh.
and even potentially feel emotions.
Exactly.
Yeah.
And that's where the paper starts, by breaking down the components of what an AGI mind might look like, just
Okay.
like our brains.
Okay.
It would need perception, memory reasoning, and even metacognition, the ability to think about thinking.
Okay, hold on a second.
Yeah.
AI that can reflect on itself, that's getting pretty deep.
It is.
Can you explain what exactly metacognition would look like in an AI?
Sure, so it's about having an awareness of your own thoughts and the ability to monitor and control your own cognitive processes.
Okay.
Imagine an AI that can not only solve a problem, but can also explain its reasoning,
Okay.
identify potential biases in its own thinking, and even learn from its mistakes. So it's not just about being smart, it's about being self-aware
Exactly.
and being able to learn and adapt in a way that's similar to how humans do. But the paper also highlights some key challenges in achieving this level of intelligence.
Well, absolutely. Current AI, while impressive in many ways,
Yeah.
still struggles with some fundamental aspects of intelligence.
Okay.
For example, understanding causation,
Yeah.
the why behind things.
You're right, that's a big one. You might be familiar with GPT-4V, the AI that can create incredibly realistic images from text prompts.
Yes, very impressive.
It's a huge leap forward in perception,
Absolutely.
combining language and vision.
It is.
But even that's limited compared to our own multisensory experience of the world.
Right.
And while it's great at identifying patterns, it doesn't really grasp the concept of cause and effect.
That's a key point.
Yeah.
Think about it this way. GPT-4V might be able to recognize a picture of a broken vase next to a spilled glass of water. But it can't understand that the spilled water actually caused the vase to fall and break.
Right.
That kind of understanding
Yeah.
is crucial for true intelligence.
Yeah.
And it's something we humans take for granted.
It's like the difference between seeing smoke and knowing there's a fire.
Exactly.
We instinctively understand that the fire is the cause, while the smoke is the effect.
Yeah.
And that understanding allows us to predict what might happen next,
Right.
to reason about the situation, and
Yeah.
to make informed decisions.
Absolutely.
So how do we teach AI to understand causation, to grasp those why questions that are so fundamental to how we think?
That's a question that researchers are grappling with right now.
Yeah.
And the paper explores several potential solutions.
Okay.
One fascinating approach involves combining traditional deep learning, which is great at finding patterns in data,
Okay.
with symbolic reasoning, which uses logic and rules to represent knowledge.
So it's about blending the brute force data crunching of deep learning
Yes.
with the more structured logical thinking that we humans are good at. I can see how that might be a step towards teaching AI to understand causation.
It's a promising avenue.
But even if we crack the code on causation, AGI can't just exist in some digital vacuum, right?
Right.
It needs to be able to interact with the world around it,
Yes.
both the digital and physical realms.
You're absolutely right. And that brings us to this second part of the paper, connecting AGI to the world.
Now that we're starting to understand what AGI needs to think about, let's explore how it would interact with the world around it.
We were talking about AGI needing to interact with both the digital and the physical world to be truly useful.
Right.
You might recall the example of Voyager, that AI that learned to play Minecraft, by writing its own code.
Yeah, that was pretty wild.
It's a glimpse into how AI could one day navigate our complex physical world.
Yeah.
But as you can imagine, there are a lot of hurdles to overcome before we get there.
Yeah, it's definitely a fascinating concept, but to be honest,
Yeah.
it's a little hard to wrap my head around exactly how AI could interact with the real world. We're talking about a level of complexity that goes far beyond playing a video game, right?
Absolutely. The paper dives into several ways AI could connect with the world.
Okay.
And Voyager is really just scratching the surface. One area the paper explores in detail is the idea of AI using tools.
Okay.
Imagine an AGI that can not only use existing tools,
Right.
like web browsers, software applications, or even physical robots,
Yeah.
but can actually create its own tools to solve new problems.
Whoa. AI building tools for itself. That's getting pretty meta.
It is.
But seriously, what would that even look like in practice?
Well, the paper highlights three main ways AI could connect with external tools.
Okay.
One approach involves directly integrating AI models with tools through specific interfaces.
Mm-hmm.
Think of it like giving the AI hands to grasp and manipulate the digital world.
Okay, so that's like the hands-on approach.
Right.
What are the other options?
Another method involves having the AI query external tools based on its needs.
Okay.
This is more like the AI delegating tasks.
Oh.
It figures out what it needs and then sends out a request to the appropriate tool.
So kind of like a super efficient project manager,
Exactly.
assigning tasks to the best tool for the job. That makes sense. What's the third way?
The third approach focuses on using language as the interface.
Okay.
This means the AI communicates with tools through natural language instructions,
Mm-hmm.
just like you might ask a human assistant to do something.
So the AI becomes the ultimate multitasker, coordinating all these different tools through the power of language.
Right.
But wouldn't that require the AI to have a ridiculously deep understanding of language?
It would.
We're talking almost human-level comprehension, right?
You're hitting on one of the biggest challenges for this approach.
Okay.
Current AI models are getting better at understanding and generating language,
Uh-huh.
but they still struggle with the nuances and complexities of human communication.
Right.
Think about all the unspoken assumptions, the contextual cues, the subtle inflections in our voice that convey meaning. AI has a long way to go before it can truly grasp all of that.
Right, because asking an AI to book me a flight to Paris is one thing, but what if you have very specific preferences? Like, you want a window seat, a vegan meal, an extra legroom.
Exactly.
Trying to explain all those little details to an AI could be incredibly frustrating.
It could, and the paper really dives into those complexities,
Yeah.
highlighting the need for AI that can handle ambiguity, understand context, and even interpret those unspoken social cues that guide so much of human interaction.
It's like teaching AI to read between the lines to understand not just what we say, but what we mean.
Exactly.
That seems like a pretty tall order, but before we get too lost in the hypothetical,
Sure.
I'm curious about whether any of these approaches to connecting AI with the world are actually working in practice.
Right.
Are there real-world examples of this stuff happening?
There are, and they're pretty impressive.
Right.
The paper discusses several examples of AI systems that are already using tools in fascinating ways. One example involves AI agents that can interact with web browsers
Okay.
to perform tasks like booking a hotel or ordering food.
Mm-hmm.
These agents can understand web pages, fill out forms,
Wow.
and even interact with those dreaded customer service chatbots.
Wait, AI that can deal with online customer service?
Oh.
Now, that's something I can get behind, but seriously, are we talking about AI that can actually understand what those chatbots are saying and respond appropriately?
That's exactly what's happening, and what's remarkable is that these AI agents are able to learn and adapt over time,
Really?
becoming more efficient and effective at navigating these complex online environments.
That's both amazing and a little scary. Are there any other examples of AI using tools in the real world?
Another area where AI is proving to be a powerful tool user is in scientific research. You're probably familiar with those massive language models like GPT-4.
Yeah.
But did you know that researchers are now using AI to analyze massive scientific data sets, identify patterns,
Wow.
and even generate hypotheses that human scientists can then investigate?
So AI is becoming a research partner, helping scientists make sense of all that data. That's fascinating.
It is. There are even AI systems that can control laboratory equipment,
Okay.
allowing them to conduct experiments autonomously.
Whoa, AI scientists running their own labs.
It's happening.
That sounds straight out of science fiction. But it also makes me wonder,
Yeah.
If AI is getting so good at using tools, could it eventually design and build its own physical robots?
That's a question the paper explores in depth.
Yeah.
And it's one of the most intriguing and potentially unsettling aspects of AGI. The idea of AI creating its own physical embodiment raises a whole host of questions about control safety and the potential for unintended consequences.
We've been talking about AI using tools in some incredible ways, like a
Okay.
digital assistant booking your flights, or even AI researchers helping scientists make those groundbreaking discoveries.
That's pretty amazing stuff.
But I have to admit, when we start talking about the actual systems behind all of this, the algorithms, the computing power, that's where things start to get a little fuzzy for me.
It's a complex world for sure,
Yeah.
but that's also what makes it so fascinating.
Hmm.
The research paper does a great job of breaking down these systems into more manageable chunks.
Okay, good.
It starts by looking at model architectures. Think of this as the blueprints for how these AI systems are built.
So model architectures are like different designs for different purposes.
Exactly.
I get it. It's like choosing between a tiny house or a mansion, depending on your needs.
Exactly. Different AI models have different structures, each optimized for specific tasks.
Okay.
The paper talks about a few key architectures being used in AGI research.
Mm-hmm.
One that really stands out is something called the transformer model.
Transformer model, that rings a bell.
Yeah.
It isn't like the technology behind those massive language models like
Yes.
GPT-4,
Yes.
the ones that seem to be in the news every day?
Yeah, the transformer model has been a game changer, especially for natural language processing. It's really good at handling sequential data like words in a sentence,
Okay.
which is why it's so powerful for language tasks. But what's really exciting
Yeah.
is that researchers are now adapting the transformer model for other types of data, like
Mhm.
images and videos.
Oh, wow.
That's really opening up a whole new world of possibilities for AGI.
So it's not just about language anymore.
No.
It's about using this transformer model to understand and process all sorts of information.
Exactly.
That's pretty mind-blowing. But even with the perfect design, don't these systems still need mountains of data to learn?
They do.
Like teaching a kid with a photographic memory, you still need to show them millions of pictures.
That's another major challenge that the paper tackles head-on large-scale training.
Yeah.
As you said, training these massive AI models requires incredible amounts of computing power and data.
Right.
It's one of the big bottlenecks in the field right now.
I remember reading that it can take weeks on a supercomputer just to train one of these models.
It's a huge undertaking.
Yeah, it seems like we're going to need to invent some crazy new computers if we want to unlock the true power of AGI.
You're absolutely right. The paper gets into some really interesting developments in this area.
Okay.
Researchers are coming up with more efficient algorithms
Mm-hmm.
that can cut down on the time and resources needed for training.
Okay.
They're also working on new hardware,
Yeah.
specifically designed to handle the demands of AI workloads.
Right.
Think custom-built supercomputers optimized for machine learning.
So it's about working smarter, not just harder.
Exactly.
We're talking faster algorithms and purpose-built hardware, but let's say we solve the training problem.
Uh-huh.
What about making sure these systems can actually do something useful in the real world?
Right.
They need to be accessible and efficient, right? We can't all have a supercomputer in our basement.
That leads us to another big challenge, inference techniques.
Okay.
Inference is all about how these AI systems use the knowledge they've learned
Uh-huh.
to make decisions and solve problems in real time. The paper highlights the need for inference techniques that are fast, efficient, and scalable,
Mm-hmm.
so we can actually deploy these powerful AI systems in real-world applications.
So it's not just about stuffing their digital brains with information.
Right.
It's about making sure they can think on their feet and apply what they've learned.
Exactly.
But honestly, all this talk about supercomputers and fancy algorithms makes AGI seem like something
Yeah.
only big tech companies or research labs can access.
Yeah.
Will everyday people ever get to experience this technology?
That's a great question, and it gets to the heart of another system challenge: cost and efficiency.
Okay.
Right now, developing and deploying these powerful AI systems is incredibly expensive.
Right.
That definitely limits access to a small group of players.
Yeah.
The paper does explore some ways
Okay.
to make AI more affordable and accessible, such as model compression and knowledge distillation.
Model compression, knowledge distillation, those names sound a little intimidating.
They do.
Can you break those down for us non-techies?
Absolutely. Think of model compression like taking a huge textbook
Okay.
and condensing it down into a handy study guide.
Okay.
You're making those massive AI models smaller and more efficient without losing too much performance.
Okay, I get it. So you're not losing
Right.
too much information, you're just making it more compact.
Exactly. Knowledge distillation is kind of like having a brilliant professor train a teaching assistant.
Okay.
You're taking a large, powerful AI model and using it to teach a smaller, more specialized model.
I get it.
Yeah,
So it's about making AI more compact and efficient so it can run on less powerful devices,
exactly.
like our phones, or maybe even those tiny computers you find in everyday objects.
Oh,
Okay, we've covered a lot of ground here.
we have.
From what makes up the mind of AGI to how those systems work as we wrap up,
Yeah.
what's the one key takeaway you want our listeners to walk away with?
The biggest takeaway for me is that building AGI is not just a technological challenge.
Right.
It's about pushing the boundaries of our understanding of intelligence itself.
Hmm.
It's about grappling with profound questions about what it means to be human and what kind of future we want to create.
And as we've seen, it's a future with incredible potential, but also potential risks.
Absolutely.
Creating AGI is a monumental undertaking,
It is.
and we've only just begun to explore the possibilities. This research paper was a great jumping-off point, but there's so much more to discover. We encourage you to check out the original paper and continue your own exploration.
It's a fascinating read.
What aspects of human intelligence do you think would be the hardest to replicate in AI? And if we do succeed in building AGI, what role will humans play in a world where machines could potentially outthink us? We'll leave you to ponder those questions.
Good questions to think about.
Thanks for joining us on this deep dive into the fascinating world of AGI. Until next time, keep exploring, keep questioning, and keep diving deep.